مرحبا. تست. مرحبا. سوري أنا بس بدي أتأكد. أوكي. Oops, sorry. What is the sound of a rectangle? You've all heard of Pythagoras, the father of geometry. This guy was really onto something because he observed things that are just incredible 2,500 years ago. So what he noticed, and he was the first to notice this, was that if you know how music is made, music is basically a vibration, right? So if we have a string, a guitar or oud string, music is made by the string vibrating. And we all think that it's just a vibration. But what Pythagoras noticed 2,500 years ago is that a string, the sound that we hear from the string is not actually coming just from the string itself, from the vibration of the whole string. The string is actually vibrating, like you see in the second line, as if there's an imaginary node in the middle of the string, and it's vibrating at exactly the same frequency on both sides. And not only that, it's also as if it's dividing into 3 different segments with 2 different notes, and all 3 are vibrating at the same time. And 4 and 5 and 6 and 7 up until infinity. So we have so many different vibrations that get smaller and smaller, and every time it gets smaller, the sound gets higher. It gets like sharp, and then we stop hearing it. And it's the addition of all these sounds, all these what we call overtones or harmonics, the addition of these sounds is what our fabulous ear, which is an incredible organ, it translates these sounds, it adds all of them together and makes us hear the illusion of one fundamental note, which we hear as the fundamental note that we actually think we're hearing. So that ratio, these are called overtones, and this is the overtones in musical notation, and it just goes on forever. This is just the very first, okay? And then on the second line, we have what we are seeing here, octave, perfect fourth, minor third. These are intervals. What is an interval in music? It's if I play 2 notes at the same time, I make an interval. If I play only 1 note, that's just 1 note. When I play another note, I'm making an interval. And this interval is called a perfect fourth because it's a fourth apart. For example, that's the national anthem of Lebanon. And a lot of national anthems start with a perfect fourth. So a perfect fourth have a ratio. What does it mean? It means that the ratio of the note that is up, this one, against the ratio that is down, which is this one, is 4/3. Meaning this note vibrates 4/3 the times of the note downstairs. Okay? And then every interval here has a ratio. So we have a lot of different intervals. For example, I'm going to choose the perfect fourth, as you see, is 4/3. A perfect fifth is 3/2. That's a perfect fifth. For example, a minor 7, that's the sound of a minor 7. That's a 16/9. So when I was looking at these intervals, I couldn't help but notice that there are ratios that I see in other places other than music. For example, you probably, if you are aware of aspect ratios and screens, you have probably now noticed the same thing. The screens of TV screens and computer screens are mostly either 5/4 or 4/3 or 3/2 or 1/1. 1/1 is a square, or 16/9, which is the YouTube version. Now, the latest YouTube video is 16/9. So when I looked at that, I was like, this is really crazy. Like, it's definitely coincidence because they definitely didn't make the screen ratios because that's the interval in music. And that raised the question, our perception of beauty really innate? Like, do we see beauty? Something sounds beautiful. Does it mean that it also looks beautiful? In that case, which means that if I have 2 different spices that are in terms of frequency, if we can measure the frequency, are 3/2, we're probably going to like the taste then. And it's the same with maybe sense of touch, but we still didn't get there. So this is how the idea of what is the sound of a rectangle came to me. So for example, I'm going to put this a little bit into action, and that's for fun. For example, this is Happy Birthday. Happy Birthday, the ratio, the intervals are a unison, and then a second, and then a second, and then a fourth, and then a third. So, okay, so this unison, that's a second, that's another second but down, that's a fourth, and that's a minor second, okay? So if I put these ratios like we saw before, so I see that the unison is 1 by 1, the fourth is 4 by 3, and etc. If I put them in terms of rectangles, I'm gonna get, this is like as if we're playing Happy Birthday, but in rectangles. And this has also sparked another idea in me. There are people who probably have difficulties maybe because they have a different brain circuitry that is wired in a way that they have a problem reading letters maybe, but they are very, very good at visuals and at colors and at shapes. So we could actually write music for these people, so we can train them to see rectangles, and then they can actually directly hear the sound. So this would be Happy Birthday in rectangles, and the difference in colors, it means that green is go up, which is like, and then orange is go down, so we go down, you know. So this is like a method of composing music. And then this is by the way, the cover of my album. It's called Lisan al-Tarab. So this is a series of album in a chord, which is the major chord. So that's the major chord right there. And here I made another chord. That's a C7 chord. A C7 chord is a very bluesy chord. I'm going to give you an example of what blues is. You're going to directly be familiar. It's like saying, you recognize the sound. And this chord, this is the main chord of the blues scale. So if I have to put a chord, a C7 chord in rectangles, I'm going to get this kind of shape. And it actually looks good. And it's funny because it's, to me as a musician, as somebody who's inside this world, I look at this chord, I look at this series of pictures, and I actually feel it sounds like a C7 chord. So now how is this related to rhythm, which is my main passion is rhythm. And here I noticed that the relationship between a 3/2 ratio in interval is very much related to a 3/2 ratio in rhythm. So a 3/2 ratio in rhythm means that every 3 notes, every 3 beats, there are 2 beats that are played at the same time. This would sound like this if I'm playing 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. So the sound, that's the sound of a 3/2. It's very African. And there, as we saw before with Pythagoras, that 3/2, these are 2 waves that are the exact length, but they are vibrating at 3/2 a ratio. So this is the fifth. And this is the rhythm that I just played. Now what I'm going to show you is that I found a way to prove that actually rhythm is harmony and harmony is rhythm. What is harmony? Harmony is just playing chords under a melody. And then, so harmony is made up of many notes. And then I'm going to show you now a rhythm that sounds like samba. And then I'm going to speed it up so fast. Think about the cinema. Cinema is called motion picture. Cinema actually is an illusion, right? Because what you're seeing, you're looking at the film, you're seeing things moving, but what you're actually looking at is pictures that are passing by so fast that your eye can't see the break in between. So it sees it as the illusion of a motion picture. And it's the same with sound. So if I play a rhythm so fast that your ears stop hearing the distance between a beat and the other, it's going to start hearing it as continuous. And then we hear it as a chord. And that was, and this is going to be now a samba rhythm that when I'm going to speed it up, be careful, it's not going to be too loud, but it's just going to be maybe a little bit irritating if you have tinnitus, but I don't think anybody of you have tinnitus here. It's gonna become a minor chord, and I'm going to show you on this keyboard how it is a minor chord. So that's the samba. I'm going to make it really slow for now. So here we have If you notice, we have many different rhythms. Now we have to put it up a little bit, sorry. Put it up a little bit, please. So we have ka, 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 ka. This is playing the 5. And then you have ka, 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 then ka, 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 ka. This is the main. And now I'm going to speed it up, and you're going to hear a minor chord. Okay, I'm just gonna take it out just so you relax your ears. Okay, so now we're gonna hear it again, and you're gonna hear you're gonna hear this. I mean, on the piano it sounds very beautiful. Here it doesn't sound as beautiful, but these notes, when I sped them up so fast, they are now vibrating at a frequency that, for example, here it's 330 hertz means 330 times per second. So 330 times per second, any sound that you find in nature, if you can play it at 330 times per second, you will hear the note of that sound. So here, everything is playing so fast that it sounds like this chord. So you can hear it? Nobody hears it? Should I put the piano up a little bit? Maybe I should put the piano up. Just for a second. So focus. Stay with me. Stay with me, and you will hear it. Okay, it's pretty obvious. Okay, and now the fun thing is that when now we have this chord, and then I'm gonna slow it down again, and then we come down from a chord to an actual rhythm, and it's like we're going from universe to another. It's pretty crazy. And now finally, our ear is hearing the difference between the notes, and now, okay, it's a rhythm, but there's no way we can hear it. So I actually believe that because first there was rhythm and then there was melody and harmony, I believe that it took tens of thousands of years for humans to start hearing the harmony out of the rhythms they were playing back 40, 50,000 years ago. So that's the illusion in music. And another thing that I really like to experiment with is translating poems to music, but really translating a poem to music, like letter by letter. So I took this poem by Dareen Hotait, and what I did was that I used numerology. So numerology, that's an ancient science. Every letter has a number, and it goes like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it goes 20, 30, 40, 50, 60, 70, 80, 90, 100, 200, 300, 400. And that's in Arabic. And the same was applied later on to English. So what I did is that I took these numbers, and I put them on a keyboard by terms of half steps. So 1 represented 1 half step from C, 2 represents 2 half steps from C. And then I will get these numbers over a series of keyboards. For example, let's say Saudi. So SA. Okay, so I look at this pattern here. What is S? S is 100 and A is 1. So I go back to this one. Where is 100? I see 100 here. That is E. Where is the laser? So this is 100 E, and then 1 here is C sharp. So SA would make this note. Okay? So, and then I did this over a whole poem. And I tried to compose music based on this. It's a little bit crazy, but I hope you enjoy it. So we're going to listen to the music now. So thank you. So every sound you were hearing with this, like subscribe, and it's all from that system. It was really, really a fun experiment. And in this, I was, I mean, obviously I went a little bit crazy, and I had maybe 2 weeks where I didn't have much to do. So because I also did the video, so I had to learn editing and stuff like this. But with this, I was also like trying to show the scope of composition, because composition is inspiration. But for me, composition is two things. Is half of it inspiration, and another half could also be just science, where we force ourselves to, we put rules to ourselves to use certain elements, and then we stick to them, and then we try to force that, and then some more creative juices that we would never have thought existed will all of a sudden go up, you know, go out from us, and that's what happened with this. Thank you so much.
Uh, wow, Tarek, this is a real innovation that I saw in everyone. That's really, really interesting. And I don't know, I always believe that music helps you to think differently and inspires you. And what you showed us, it's just a proof fact for that, and that's how you go with it. But I want to ask you maybe now, how the reflection of the letters to the music came into one picture for you? Like how you had this link in between.
How did I think about this?
Yes.
To be honest, I don't remember. I think I was into numerology for a while.
Okay.
So, and then I got the idea, really, ideas just come, you know? Like for a creative person, you're just sleeping and you wake up, you have an idea. You just don't know how it comes. It comes from the subconscious while you're sleeping, sometimes maybe in a dream, but you don't remember the dream. So you don't know if you dreamt it or not.
Yeah, it's in your subconscious somehow.
Yeah,
somewhere.
you wake up and there's something in your head that tells you to do something.
Yes.
And I think I just got the idea randomly.
That shows how much you are so into music, and
Yes,
you
it's
live
my life.
it, you breathe it.
Yeah, it's everything.
You're so into it.
Yeah.
Okay, I'll leave the attendee if you have any questions for you to share with our very special pianist today, Tarek. If you have any question.
I think it was all clear.
It was so clear. I'm fine. Oh, we have here a question.
Thank you very much, Tarek. It was an amazing presentation.
Thank you.
Very connecting a lot of different things. In your composition, you have this code or this mapping of letters to notes.
Yeah.
What about the rhythms of these notes?
Yeah,
Did
no,
you
the
have
rhythms-
another system for that?
No, so what I focused on was that I put the rule that I put to myself is that every letter of the poem and its respective pitch has to be there in the chronological order,
Yes.
the way it appears in the poem. But then I'm free to do whatever I want with the rhythm and the harmony, you know? So that was it. So then I'm forced to use these notes in whatever way I want.
Thank you.
Yeah, pleasure.
That push you to think more like also innovatively about the rhythm that you want to build with whatever
Exactly.
notes you have.
Yeah, because the letters are inspiring me to do something
Yes.
otherwise I would not have thought about.
Yes, yes. Actually, I was thinking the same. I was like, how this can be all together, and that's what counts.
Yeah.
Another question? Okay, we have two here. Where is our volunteer? Oh, here.
Thank you so much. That was really interesting. I was curious, when you said you found the rhythm maps to the harmony, do you find that, in your experimentation, that modern music, you find that mapping still? So you said like the samba rhythm kind of maps to a minor chord. Do you find like samba typically focuses on minor harmonies? And like same thing with blues, does it typically map to?
That's a very, very
perfect
interesting
fifth
question.
and perfect seventh or dominant seventh chords?
Yeah, that's a very interesting question, and I asked myself this question, and I'd like to say yes, but I can't confirm it. But somehow I got the idea. It's like, because Brazilian music is very melancholic, so I asked myself this question: could it be because the samba rhythm is a minor chord? But I think we can never know. But we can ask though, and it's nice to just keep that open. Yeah.
We have you? Okay, can we have here the mic, please?
Okay, thank you very much. It was very helpful. If I want to learn music, does it take time and does it very hard to know and more about music?
How old are you?
14.
14? It's not hard. It's very easy. So do it. No, so it's really, learning music is like learning anything. Like learning to ride a bike, learning to eat. Do you remember when you learned to eat? You probably don't remember how long it took you, if it was hard, right? Because you were passionate about eating. You loved eating. It was required for your body to eat, so you just did it, and now you eat very well. So music is the same. Music requires just passion. Just have to be passionate. If you like it, do it because it will reward you. So the food is a reward for the body. Music is a reward for the soul.
And also following a very inspirational pianist would be also a good idea to keep you move on through the journey of learning whatever instrument you'd like to choose learning. Thank you so much, Tarek. That was great having you here, and hope to see you.
Yeah.
Thank you.
Thank you so much.
Thank you.